Hi everybody, in this video we are going to discuss about how we can perform insert at the end in a circular linked list. So first we will be discussing about the case when the list is empty. When the list is empty and if you have got a new node like this, then what we will be doing, we have to make the next part of the new node to point to itself, because the concept of circular linked list tells that the next part of the last node should contain the address of the first node. When there is only one node, that is the first node and that is the last node as well. Okay, so we have to make this, and also we have to make the head of the list to point to the new node. This is what we have to make. But just recall that the same thing only we made when we were doing insert at the beginning also. So what we can do is, when the list is empty, we will better call insert at the beginning, right? So that will take care of these steps, whatever has to be done, and we can just return whatever insert beginning returned, right? Now let us consider the general case when there is when there are some nodes in the linked list. We will consider that case. Let us assume that there are 5 nodes in the linked list like this, okay, 10, 7, 15, 20, 19, and I am going to insert this particular new node with data 11 at the end of the linked list. Then what are the steps that I have to make? Actually, I have to make a connection between the current last node and the new node, right? But how will I locate the current last node? I do not have any means, isn't it? So I have to declare a temporary pointer, and I should move the temporary pointer till the next part of the node is equal to the head. I should have a condition like that, and I will be telling temp equal to temp next, so that I will come here. After I come here, what should I do? I must make the next part of this particular node to point to this new node, and the next part of the new node should point to the head, because this is the new last node. Last node's next part should be equal to the head of the list, right? So let us formally write the algorithm. The input for this operation is the list and the data, and we have got already a create node function. So using the create node function, we will create a node and put the data in the data part, and address of that particular node we will make it as null, and we'll be returning the address as new node. Now you have to check whether new node is null. This is the case which will occur when there is no memory in the system at all. That is a very rare case. So anyway, we have to check whether it is null, and we have to return. If the value is null, then we have to return false. That is, insertion is not being done. It's not successful. Otherwise, in step number 3, you are checking if the list is empty. If the list is empty, then you will just call the insert beginning function, and you will return whichever is returned by that particular insert beginning function. Otherwise, declare a temporary pointer temp, move temp to the last node, and make next part of the last node to have the address of the new node, right? That's what we made when we were illustrating also. And then you have to make the next part of the new node to contain the head, right? These are all the steps that we will be following. Let us implement this in C language. So the declaration is already done. Insert end, you can see the list should come as reference, as address, because you want the changes to be reflected in the place where it is called also. Then this is the place where we will be writing the function, right? And the return type of the function is going to be int, indicating whether the operation is successful or not. We will return 1 for success and 0 for not success, okay, or failure, because C language do not have a Boolean data type, okay. So let me send the list by address, okay. So I should tell L, and I'll be telling int D, right? This is the data, and here I'll be declaring 2 pointers. One is temp, other one will be the new node, right? And then you can call the create node function, okay, and you have to parse the data, right? And after the create node function is finished, it will come back, and you have to check whether new node is equal to null, right? Either you can tell new node equal to null, or you can tell not of new node, because this is new node, actually null is false. So when I tell not of is no new node, then if it is null, the condition will be true, right? If it is null, then what should I do? I should just return false. How I am going to indicate false? By 0, right? Otherwise we are going to proceed. In this we have to follow the algorithm, whatever is being told. Let me check if the list is empty, right? So if is empty, right? Actually before even yeah, we can check this step even before creating the node. That's better, because InsertBeginning will also create a node. That's the right choice. So let me call is empty, okay, and I have to call by passing the list, not its address. So I'm putting a star here. I'll be calling and returning whatever is returned by the InsertBeginning function. Okay, so InsertBeginning, and I'll be passing L and D, right? So if the list is empty, that's done. Otherwise we are creating the new node, right? And you will declare a temporary pointer now, right? You will, otherwise you will create a temporary pointer, and you will initialize the temporary pointer will be equal to the head of the node, right? That's what is done. And you have to move till the last node. So how will I know the last node in a circular linked list? When the next part of the node is equal to the head of the list, right? So I have to tell while temp next not equal to head, right? And I'll be telling temp equal to temp next. So here after this, what should we do? We should make the next part of the last node to contain the address of new node, right? So let me tell temp next is equal to new node, right? And you have to make new node next part is equal to the head, right? So the connection will be made. Let us just visualize. What we are doing is, first I am making, actually my temp is here, I am making the next part of the last node to point to the newly created node, and then I will be making the next part of the newly created node to be equal to the head, right? So that is what is done, and we can return 1, indicating success of the operation, right? So we can compile and check this code whether it is right, and we will check executing also. Already I have made a call here, right? We can make different calls and also check. So first of all, let me compile the cll.c. I am doing only compilation, so we give the -c option and we redirect the object code to cll.o, right? And I have used G++. Let me use C compiler, right? -c -o, right? But C++ is a superset, but better to compile with the exact compiler, right? Now I have made a mistake. That is, I have given us head. Head is not known. It should be given as L head, right? That's the mistake. So let me correct it. Here is the line. Let me tell L and then head, right? So there is no error in this. Next we will compile the application file. So the command will be gcc that particular file, and only compilation redirect the object code to cll.a.o, right? After this we have to invoke the linker with these two object files. Let us give that. That's also fine, and let us try executing it, right? So what we are seeing here is, let us see the main. What we are doing, we are calling InsertBeginning 1, right? So let us try to write it here. So 1 will be inserted, and then you are calling again InsertBeginning 2. So 2 will be inserted before this, and then you are calling InsertEnd 5, right? So 5 will be called here, InsertBeginning 3 and InsertBeginning 4, right? So let us see whether we are getting 4, 3, 2, 1, 5. Looking fine. Okay, if you want, we can change and also see. Let me change this to InsertEnd, right? Then what should I get? Actually 1 is in the beginning, right? And 2 is also in the beginning, and we have got 5 at the end, okay, and 3 at the beginning, and 4 at the end, right? So you should get the elements 3, 2, 1, 5, 4. Let us check it. It's enough if we compile only the application file, because we have not made any changes to the cll.c, right? And you link it and execute and see 3, 2, 1, 5, 4, right? Looking fine. So I will share the code in the GitHub. You can try it by yourself. Thank you.